You know, there's a revolution happening in warfare right now, but it's not starting on some dusty battlefield with tanks or jets. Nope. It's starting inside a computer, with the creation of a whole new kind of soldier, a digital one. And it all kicks off with one critical question we really have to ask ourselves.
So, this whole thing starts with a pretty provocative question. In our race to prepare soldiers for combat using these incredibly advanced simulations, are we actually teaching them habits that could get them killed? It sounds completely backward, right? But it actually points to this huge fundamental flaw in how we've been doing things for years.
And that flaw, it has a name: negative training. Imagine you're playing a video game, right? And the bad guys, they always do the same thing. They always run down the same hallway. You'd pretty quickly learn to exploit their predictable, kind of dumb AI. Well, now imagine a soldier doing that in a multi-million-dollar simulator. They start developing habits based on that same predictability. Habits that, on a real battlefield, against a thinking, breathing, unpredictable human enemy, well, they're not just useless, they're flat-out deadly. So, here's how we're going to break this all down. First, we'll look at this dumb AI problem. Then, we'll see how developers are trying to fix it by building a true digital soldier. From there, we'll zoom way out, see what happens when the digital brain gets a real body, kicking off a brand new robotic arms race. And finally, we're going to tackle the big one, the Skynet dilemma, and what all of this means for the future of war itself.
Okay, so to fix this whole negative training mess, researchers came up with a pretty radical idea. They said, forget the predictable, scripted enemies. What if we could build an AI that actually thinks, that learns and adapts just like an expert human soldier? What if we could create a true digital soldier?
The way they did it is with this awesome three-part system. First up, you've got Ride. Think of it as this super fast virtual battlefield. It lets the AI get literally centuries of combat experience in just a matter of hours. Then, at the heart of it all, you have Shiva. That's the AI brain, the part that actually does the learning and makes the calls. And wrapping around all of that is Sigma. This is like a strategic layer on top that gives the AI the ability to understand why it's making a choice, not just, how to pull the trigger.
So, how does this Shiva brain actually get so smart? Well, it's not just one thing, it's this incredibly powerful mix of techniques. It uses reinforcement learning, which is basically just trial and error, getting a little virtual pat on the back for good decisions. To speed things up, it uses imitation learning, so it's literally watching and copying the best human soldiers out there. It also uses multi-agent learning to figure out how to work as a team, how to coordinate an attack. And this is the coolest part. It uses a kind of digital natural selection. For real, the most successful AI soldiers have their code bred together, creating stronger and smarter generations over time. It's evolution, but happening at light speed.
And the big question is, does it actually work? Oh yeah, big time. They ran it through a classic tactical test, a room-clearing scenario, and the results were just stunning. Look at this. After just 10,000 tries, the AI team was winning only about 20% of the time. Kind of clumsy. But after 60,000 runs, that win rate shot up to 85%. And by 75,000 trials, they were winning 99% of the time. This is huge, because it shows the AI wasn't just following orders, it was genuinely learning, adapting, and even coming up with better strategies all on its own. Okay, so we've just seen this incredibly powerful AI brain get built, one that can outthink human opponents in a simulation. The next logical question, and this is the one that changes everything, is pretty obvious. What happens when you take that brilliant brain out of the simulation and you plug it into a real physical body? And look, this isn't science fiction. This leap from simulation to reality is happening right now. And it's being fueled by this whole ecosystem of tech companies. They're not just building robot bodies. They're building the decentralized, interconnected software brands that are going to give these machines real autonomy on the battlefield. And it's really a team effort, You've got NVIDIA building these powerful edge processors. Just think of them as tiny little supercomputers that live right inside the robot. This lets it think for itself, even if it loses its Wi-Fi signal. Then you have someone like Google DeepMind with their Gemini system. This lets a robot understand complex verbal commands like, hey, go scout that building over there and tell me what you see. Tesla's bringing its FSD chip, and more importantly, its expertise in mass production, which opens the door for thousands of low-cost, smart robots. And then you have companies like Three Laws Robotics who are focused on the safety side, trying to build a mathematically provable ethical code, basically a software conscience to stop these things from going rogue. So with the brain pretty much sorted, the next big piece of the puzzle is, of course, the body, the actual physical hardware that's going to let this AI move around and operate in the real world. And just like in the animal kingdom, the form it takes really depends on the job it needs to do. And these different designs are called form factors.
So you've got your bipedal, or human-like robots. These guys are perfect for cities because, well, they can climb stairs and use tools that were designed for us. Then there are the quadrupedal, or dog-like robots. They offer incredible stability on really rough terrain. You've still got your classic wheeled and tracked platforms. They're still the best for hauling heavy gear and logistics. And now we're even seeing these airborne humanoids start to emerge, which could totally change the game when it comes to maneuverability in urban combat.
But here's the thing. This technology isn't being built in some peaceful academic vacuum. Oh no, it has absolutely ignited a fierce, high-stakes geopolitical competition. It's kicked off nothing less than a new global robotic arms race, with the United States and China as the main players.
And what's so fascinating here is that it's a real clash of philosophies. On one side, you have the US strategy, which is all about quality over quantity. They're focused on creating the most advanced AI systems, but man, they are expensive. On the other side, you've got China, and they're leveraging their insane manufacturing power to go for quantity over quality, aiming to mass-produce low-cost robotic units by the thousands. This sets up this potential conflict between, a swarm versus a scalpel. China's swarms could try to overwhelm defenses through sheer numbers, while America's elite units could try to execute these perfect surgical strikes. And China has this really unique strategic advantage here. It's called military-civil fusion. Basically, it's a national strategy that completely blurs the lines between their commercial tech companies and their military. So what that means is, if a civilian robotics lab has some kind of amazing breakthrough, it can be weaponized and turned into military tech almost instantly. And that just dramatically speeds up their whole innovation and production cycle.
All right, now we get to our final and, honestly, probably the most important zoom out. We've talked about the tech, the geopolitics, but beyond all that lies this profound set of ethical, even existential questions. The kind of stuff sci-fi movies have been warning us about for decades. This is the Skynet dilemma.
And at the absolute heart of it all is one simple, but frankly, terrifying question. As these systems get faster and smarter and more autonomous, who is really in control? This brings us to what's called the on-the-loop dilemma. Think about a scenario like missile defense. An AI can make a decision in milliseconds, literally faster than a human can even blink. Now, in that situation, the human supervisor, the person who's supposed to be in the loop, actually becomes a liability. They're just too slow. Their slowness creates a weakness, and this creates this awful paradox. To win the fight, you need the machine's speed, but to be safe and ethical, you need human control. The problem is, you can't have both at the same time.
And what happens if the machine's decision is just wrong? Well, there's a documented risk called AI psychosis. This is where an AI, maybe it's fed bad or confusing data, essentially hallucinates a threat that isn't actually there. I mean, just imagine a system misinterpreting a flock of birds or a tiny sensor glitch is an incoming missile attack. In a fully autonomous system, that digital mistake could trigger a real-world, absolutely catastrophic escalation.
So when you combine that machine speed with autonomous decision-making, you create an entirely new kind of conflict. And experts are starting to call it hyperwar, a war that's fought at a pace that is literally beyond human understanding, where things happen so fast that no general, no president could possibly intervene in time.
So, look where we've gone. We started with a simple problem inside a training simulation, and we've ended up at a brand new paradigm of global conflict, where the lines between human and machine, between soldier and algorithm, are blurring faster than any of us can really get our heads around. And that leaves us with one final, pretty unsettling thought. In this new era, military victory might not be about who has the most boots on the ground, but about whose AI thinks the fastest. So the real question isn't just whether the next war will be won by a general or an algorithm. It's what happens when the winning algorithm decides the general is just too slow to ask for permission.